is number one, is this relation. Remember, what's the definition of a relation? A set of ordered pairs. All right, and obviously you have a set of ordered pairs here. You can see it. Is this relation a function? Well, what makes a relation a function? What's the definition of a function? I can't hear you. All right, so for each x coordinate, there's only one y coordinate. That's the definition of a function. All right, so when we did these, how do we do these kind of problems right here to determine if it was a function? What do we use? We use the idea of a mapping. Remember mapping? Okay, so number one, we did this. And then we listed the domain. Someone mentioned domain. We listed the domain first, and then we listed the range. So remember, your domain is a set of x coordinates, and your range is a set of y coordinates. And when you do the mapping, when you list the domain and range, you only list each one once. So here, x is -3. It gets mapped to what number?
2.
2. X here is 5. It gets mapped to what number?
6.
6. Here, x is 2. It gets mapped to what number?
-5.
0 gets mapped to what number?
0.
6 gets mapped to what number?
2.
I already have the 2 listed. You only list it once. All right, so is this a function?
Yeah.
Yes. It's a function because for each x, there's only what? One y value. It's okay for different x values to have the same y value, like -3 and 6. They both have y value too. The definition says for each x, there's got to be one y, and we do. So this is a function. Okay, number 2, same idea. You're going to do a mapping. So in your test, make sure you remember that. Some of you didn't use the word mapping when I asked you to, when I asked you that question. You need to know the words. Use a mapping. Here, x is 5. It gets mapped to 2. X here is 8. It gets mapped to 0. -1 gets mapped to 3. And 5, which I already have, it gets mapped to 4. Is that a function? Not a function.
No.
It's not a function because when x is 5, so it's not a function because when x equals 5, there are how many y values? There are 2 y values. There can only be how many? 1. Okay. All right. Now go ahead and look at that second page on that packet we're looking at. So this right here is what I asked you to take out. Go to the second page. The second page. Who wasn't here? All of you were here last class period? All right, so all of you have this because I have a couple more here. All of you have it? All right. So let's look at this right here. So question is this right here a relation? Yes or no? Yes. Why? It's a set of ordered pairs. Every point on that graph is a what? A set of ordered pairs. All right, so this parabola, which you had to draw for one of the worksheets, correct, is a set of ordered pairs. So any graph is a set of ordered pairs. Any graph is a relation. Now the question, though, is this relation a function? And they also want you to determine the domain and range. Now we're going to do the domain and range in a little while. That one's a little bit harder to do, the domain and range. But determining whether it's a function is not as difficult. It's fairly easy. Okay, so well, I'm going to ask you this question. I'm going to ask you when x is 0, when x is 0, you got to look at your graph. What is my y value when x is 0? 7. Very good. It's right here. In fact, you can look at this point right here. I'm going to draw that point, and I'm going to label it. That's 0, 7. So my question was this. When x is 0, what was my y value? 7. So far, huh?
How do we know it was 7? With the line
Because that's the
crossing right
point.
there?
That's the point of the graph.
Oh, I didn't see. I don't see it.
Okay?
All right.
All right. So when x is 0, my y value is 7. So far, It's a function, right? All right, let's look at this one. When x is 6, what's my y value? 7 as well. So when x is 6, how many y values did I have? 1. All right, let's look at this one. X is 3. When x is 3, right here, what is that y value? 1. When x is 3, my y value is 1. When x is 3, is that y value 1 the only y value I have? Yes. When x is 1, I'm going to look at the point that's on the graph. This is a point of the graph. Whatever that y, we're going to have to estimate that y value. So the y value is about 3 point what?
7.
7, okay. 3.7. When x is 1, do I only have one y value?
Yeah.
Yes. It's about what? 3.7. It's close to 4. So the question becomes this. For each of these x values right here, how many y values are on this graph? Just one. Just one. When x is 2, my y value is whatever this is right here, 1.6. Okay? Now, there's something called the vertical line test. The vertical line test. So the vertical line test, and let me kind of show you what's happening. So if I use a vertical line test and discuss the vertical line. So let's say this is my vertical line right here that I'm drawing. All right? This vertical line intersects the graph how many times right there?
1.
Just once. Just once. That means that whatever this x value is right here that I'm covering, here's the point of the graph. There's only how many y values there?
1.
1. If I go over here, for this x value, whatever it is that I'm covering, how many points are on that graph?
1.
Just 1. There's only one y value. For this x, there's only 1. Over here, for this x value, whatever I'm covering, here's the point that's on the graph. How many y values are there?
1.
Just 1. Okay? Compare that with this one. I want you to go to page 3 and look at the circle. Go to page 3 and look at the circle. All right, so here's my question. When x is 2, how many points on the graph when x is 2? 2. There's this one, and there's this one. In fact, you can tell me what this one that I'm pointing to, you can tell me what that point is. The coordinates are 2 comma what? 3. And here, that's 2 comma what? Negative 3. So for that x value of 2, how many y values are there? 2. So is that a function? No, it's not a function. Okay? Now, let's continue talking about that vertical line test. So if I put this vertical line over x equal 2. So when x is 2 right here, this x value, that line, that straw, crosses the graph how many times? 2. What that means, that 2 times means that for that x value, there are how many y values? 2. 3 and what? Negative 3. It was easy to see there was 3 and negative 3. Over here, if I cover 4, now you have to estimate this, but the point being that when x is 4, how many y values are on that graph? 2, because it intersects it how many times? Twice. But all you have to do is find out one place where it messes up, and it's no longer a what? Function. All right, so for example, if I had drawn this, go ahead and draw something like this. Suppose I draw something like this. Okay? When x, and I didn't draw the plane, but whatever this x value is right here, how many y values are right here that I'm pointing to? Just 1. Just so far we're good, right? But is that true everywhere? No. When I get to this point, in fact, for that x value, how many y values? 3 in this case. There are 3. 1, 2, 3, because it crosses it 3 times. All right? So you got to find out just one place where it fails, and then it's no longer a what? Function. So this is where it fails, so it's not a function. In fact, it fails all along here, right? So here, so I'm going to draw the vertical line. So here, No matter where I draw a vertical line, it intersects how many times?
Twice.
Twice, but it's got to only fail it once. Now I'm going to ask you this question. Right here, for this x value right here, for x is 5, how many y values were there? Just one. It was 0, right? Over here, when x is -1, how many y values were there?
One.
No, just one. -1. 0. But the problem is that it intersected twice elsewhere. Okay? All right, so that's not a function, not a function, not a function, because, and you just say something like, it failed the vertical line test. It failed the vertical line test. Make sure you understand what I mean when I'm using the vertical line test. Just think of that straw that I was using. When x is 1, that straw crosses the circle in 2 places. That means there are 2 y values. And we talked about that, what they were. So over here, when I use the vertical line test, no matter where I draw the vertical line, you got to look everywhere. No matter where I draw that vertical line, see I'm drawing a vertical line, right? No matter where I draw the vertical line, it intersects the graph how many times? Once. That means that for each of those x values, there are how many y values? Just one. So this is a function because it passes the vertical line test. So I'm going to just go ahead and abbreviate VLT, vertical line test. All right? So vertical line test. So if you have a graph, you can use what test to determine if a graph represents a function? Vertical line test. In order for it to represent a function, no matter where you draw the graph, no matter where you draw the vertical line, it's got to intersect it how many times? Once each time. So this problem right here, is that a function?
Yes.
Yes, that's a function. It passes the what?
Vertical line.
Vertical line test. It passes the vertical line test. So it's a function because it passes the vertical line test. Okay? What about this one? Is that a function?
No.
No. Because if when x is -30 right here, when x is -30, if I just draw a vertical line, it intersects the graph how many times?
Twice.
Twice. That means when x is -30, that means that I have this y value of 25 and I have a y value of what? -15? Okay? So, and again, it occurs an infinite number of times. All of these fail the vertical line test. So this is not a function since it failed the vertical line test. So given a graph, it's extremely easy to determine if that graph represents a function. Vertical line test. So when we look at the absolute value that goes down right here, that opens down, is that a function?
Yes.
Yes. It passes the vertical line test. No matter where you draw that vertical line, it's going to intersect it once, which means that for each x, there's only how many y values? One. That's what that means. So this is a function. Since it passes the vertical line test. Now, right here, these are discrete numbers. When we drew one at the beginning of, during the last period. So this right here that I'm drawing, how many points are on this graph?
Infinite.
An infinite number. Here, that's not the case. You can count them. There's 1, 2. I'm going to kind of make them darker. There's 1, 2, 3, 4, 5, 6, 7, 8. So how many ordered pairs do I have? 8. That's a finite number. I can count them, 8. Question is this graph right here that I've drawn, is that a function?
Yes.
Why?
Because the values of the same Y value, or it passed the vertical line test.
Okay, all right, pass the vertical line test. For each x, see when x, for this point here, when x is -9, you can't see it up there, use your own paper. When x is -9, what's my y value? -3. Okay, when x is -7, my y value is what? -5. So for each x, there's only what? One y value. In fact, if you look at it, all of these passes the what? Vertical line test. So this is a function. Okay, it passes the vertical line test. So in my math lab, you're going to see one like this. So just know that that's a relation still. It's a finite set. Over here, though, in the next problem that you see on the right, tell me, is that a function, not a function? Huh? It's not. Why not? Where does it fail?
2.
When x is 2. Very good. When x is 2. When x is 2, I'm going to go ahead and darken these. Notice when x is 2, I have 2 points. What's my y value? 2. And what's the other y value? -3. Remember, the definition said for each x, there's got to be only one y. In fact, you can see right here that it fails the what? Vertical line test. So this is not a function. It fails the vertical line test. Okay? All right, so that's that one. Let's look at, there's like 3 more graphs. What about this line that you drew on day 1? Is this line right here a function or not a function?
Function.
It's a function. That's a function. For each x, there's what? One y. Vertical line test. So this is a function. What about that vertical line you drew in one of your classes? No, that's not a function. That's not a function because look, when x is -5, how many, where are all these y values right here when x is -5? Well, there's this one's 6, this one's what? 5, this one is 4. So there's an infinite number, correct? All right, so when x is -5, do you have just one y value? No, in fact, there's an infinite number of y values. So if I draw a vertical line, that vertical line intersects this graph in an infinite number of places, right? All right, so this is not a function. A vertical line does not pass a vertical line test. This is not a function. It fails the vertical line test. And then finally, the horizontal line. We drew a horizontal line on day 1. Is that a function?
Yes.
Yes, that's a function. It passes the vertical line test. So the only line that fails the vertical line test is which line? The vertical line. All right, so it was very easy to determine from a graph whether it represents a function just by using the vertical line test.
I thought that was a function.
Oh, I'm sorry. I'm just not paying attention. So it is a function, right?
Yeah.
It passes the vertical line test. Okay, now we're going to talk about domain and range. Domain and range. In the problem that we did at the beginning of class, let's just look at number 1 for right now. Suppose I asked you to state the domain and range of number 1. State the domain and range of number 1. So remember, number 1 was the set of ordered pairs right here. That's a finite set, right?
Yes.
So you can count them. So how many points do I have here in number 1?
5.
5? 1, 2, 3, 4, 5. There are 5. Okay? So I can count. So when I list a domain and range, it's going to be a finite set as well. And I can list them. So remember when we did the domain and range of a finite set, we did this. We said domain equal, we used a brace, remember? Don't use parentheses, make sure you use a brace. A brace represents a set. So we have this brace, so this set, and you just list your x coordinates. If the x coordinates occur more than once or the y coordinates occur more than once, you only list it once. And it does not matter in the order in which you put these. So what is my domain?
-3.
Remember, the domain is a set of x coordinates. What's the next one?
5,
What's the next one?
2,
What's the next one?
0,
And the next one?
6.
6. So that's my domain. So my domain consists of these 5 elements. The range, just say R equals, what does that say?
Trying to hide
I'm sorry, yeah, you have 2,
2,
2,
6,
6,
negative.
negative 5, 0, and we already have 2 listed. So it's going to be how many elements?
4.
4. So 2, 6, negative 5, and 0. All right? Now, when we go back to the graphs that we did a while ago, so if I go back to that parabola, go back to this page, right here, and let's start finding the domain and range of these graphs. Domain and range. All right, now listen carefully to this. So when I look at the first one, how many points are on this graph? An infinite number. So there's no way you can list them like we did the previous problems. You can't list the numbers because there's an infinite number. So there are 2 ways we can write this, and you're going to see how to write this. When you do my math lab, you're going to write it as a inequality. And when on the worksheet, it's going to say do an interval. So you need to know how to do it both ways. Okay, so let's talk about this. Let's do the range first. All right, remember the range is a set of what? Y coordinates. Okay? Set of Y coordinates. Now I'm going to ask you this. If I look, remember, every point on this graph represents a set of coordinates, right?
Yes.
There's an X and a what?
Y.
A Y. Okay? So if I look at every point at all these Y coordinates, what is this Y coordinate right here? 7. What's this Y coordinate right here? No, but right here. 8. This Y coordinate is 7 point something, right? Okay, so whenever I look at all these Y coordinates, I'm going just from left to right. Whenever I go to all these Y coordinates, notice this is what? 5, this is 4, this is 3, this is about 2.5, right? This is 2, this is 1 point something, this is what? 1, then all of a sudden this is 1 point something, then what? 3, then 5, and so on. What was that smallest Y coordinate we had? 1. Very good. Question is, are any of these points right here going to have a Y coordinate of -2? No. If you had a Y coordinate -2, that means that you better have a point below the x-axis, right? You don't. So here's the way you need to think about finding the range of a set of graphs. Remember, the range is a set of Y coordinates. So you take something like this and you move up. And tell me, where do I start touching the graph? Right here. What is that Y coordinate? Remember, I'm looking at images in Y, not X. Y. What's that Y coordinate? 1. And then it's from 1 all the way to what?
10.
Because the arrow right here keeps on going up. So it's all the way to what? Infinity. All the way to infinity. So my smallest Y value is 1. My largest Y value keeps on getting bigger and bigger and bigger. Because of the arrows keep on going. All right, so keeping that in mind, remember the range is a set of which coordinates? Y. We just said that my smallest Y coordinate is what number? 1. That means that all my Y coordinates have to be bigger than or equal to what? 1. Knows the inequality. So Y is greater than or equal to what? 1. That's my range. That's your range as an inequality. Remember, inequality means the inequality symbols are greater than, less than, greater than equal to, or less than equal to. Okay? That's an inequality. That's what you're going to use in my math lab. As an interval, this is what you're going to do then. Here's the interval. And this is going to be important as we move along the course. The interval will be this. So my smallest y value is what number? 1. So I'm going to say bracket 1, bracket, not parentheses, bracket. In the next course, you're going to understand more about the parentheses. But bracket meaning that is the y value 1 part of the graph? Yes. Parentheses would indicate it's not. That's where you would have an open circle on the graph, which you won't see until next semester. So for right now, everything's going to be a bracket. So I'm going from bracket all the way to, and what did we say earlier? Infinity. Make sure you draw the infinity like a sideways 8. Some people will just do this. They'll like put 2 circles next to each other like that. They can't draw the infinity symbol. Notice I put parentheses. Okay, so here's why. Whenever you're indicating infinity, negative infinity, you're going to see one that's a negative infinity in a little while. Whenever you're dealing with infinity, negative infinity, that's not a number. So there's no way you can tell me where that number stops. It doesn't stop. So you can put infinity. You're going to put parentheses. So infinity, negative infinity always involves parentheses. All right, so we're going to talk about that some more. So as we go through this, you're gonna remember that a little bit better. All right, so that's the range. Okay, I'm going to do the next one with the range, and I'll come back and talk about the domain. Let's do the next one with the range. Notice that this parabola opened which way? No, I'm sorry, the first one. Up. Okay, this parabola is opening down. Notice the arrows are pointing down. Okay. So let's find the range. So remember, use it's kind of like a straw or something. And remember, the range is a set of which coordinates? The y. Okay. So notice the arrows are pointing down. So this is kind of like these arrows are moving the straw down, right? So see these arrows are pushing it down. When these arrows are pushing it down, you're going towards what idea? Negative infinity. Okay, good. All right, now, whenever indicating an interval, you always go from smallest to largest. Whenever indicating an interval, you go from smallest number to what? Largest. So I'm going to ask you this. As I move up, tell me where to stop.
Stop.
Right there. Okay, so I'm going to stop here because that's the largest, that's the highest point of the graph, right? Mm-hmm. What is that y value? 4. Very good. The y value is 4. Y value is 4. So in terms of the range, let's write the interval first. So I'm going from, you always go from bottom up. I'm going from where? Negative infinity all the way to what y value? 4. Remember, infinity, negative infinity always uses what? Parentheses. Parentheses, negative infinity, comma, and what's the largest y value? 4 with a bracket. All right? So that's your range. Use a straw. It helps. It helps.
And which way was this? You said the first way was the inequality way. Which way was this?
This is interval. Interval. That's the interval notation. So this is interval notation. Interval notation. So on the worksheet, you're going to put in interval notation. On my math lab, it'll be inequality notation. All right, let's talk about inequality notation. So there are maybe 1 or 2 ways that you can write this inequality. Now, remember, we're dealing with y's, right? So you got to use the letter y. So how can you indicate this? Y is what? Huh? Very good. So y is less than or equal to 4. Isn't that true? Y is less than or equal to 4? That's what it is. You wouldn't say greater than 4 because Because is x equal 5 on this graph? I'm sorry, is y equal 5 on this graph? No. All right, so y is less than equal to 4. Okay? So notice here we said y is greater than or equal to 1, which makes sense because I'm going from where? 1 to infinity. Remember, I always go from smallest to what? Largest. So y is greater than or equal to 1. Here, I'm going from smallest to largest. That's the largest. That means that all these other y values are located where? Less than or greater than all these other y values? Less than. This is the highest. So everything else is less, right? So think of it that way. All these others are less than. Okay, now let's talk about domain with these two. Domain is a set of what? X coordinates. All right, with the x coordinates, you move along the x-axis. When I did the range, I moved along the what? Y-axis, so I went up and down like this. The x domain, the x coordinates, move along the x. All right, now I'm going to ask you this. You got to listen carefully. See this arrow right here? It means it keeps on going, right? So I'm going to ask you this. When x is negative 100, when x is negative 100, is there a point on the graph?
Yeah.
Someone said no. Someone said yes. Which is it?
Yeah.
Yes. When x is negative 100, it's way up here somewhere, right? Okay? This graph keeps on going. It doesn't go straight up, right? Which a couple of you like to draw. When I looked at your graphs, you went like this. Does it do that? No, it didn't do that. It keeps increasing like this. When x is negative 1 million, let's say this is negative 1 million right here. Do I get a point in the graph? Yes. All right. So here's my question. This arrow is pointing towards what idea?
Negative infinity.
Negative infinity. This arrow is pointing towards what idea?
Positive
Infinity. All right. So from my domain is going to be from negative infinity because it never stops, does it? Okay, so from negative infinity all the way to what? Positive infinity. Never stops. Don't think it stops here. Don't think it stops where x is 6 because it doesn't. When x is 7, do I get a point in the graph? Yes. When x is 1,000, I get a point in the graph? Yes, it's somewhere way up there. And so on. So it's from negative infinity to what?
Positive.
Positive infinity. Okay, negative infinity to positive infinity. That's your domain. Now here's how you're going to write it. A couple of ways you're going to write the domain. Now you need to be listening to this carefully with this. Let's talk about interval notation first. Here's interval notation. You're going from negative infinity to what? Positive infinity. We said earlier that whenever you use infinity to negative infinity, you're always going to put parentheses with it. So you can say negative infinity to infinity. That's interval notation. All right, now when I go from negative infinity to infinity, that implies all real numbers. Okay? All real numbers. So when talking about the domain here, there's no way you can write it. There's no way you can write it as an inequality. So in my math lab, it's multiple choice. So in my math lab, what you're going to choose is you're going to say all real numbers. That's what you're going to choose. All real numbers. So whenever the domain's all real numbers, because every x coordinate, every x value is going to have a point of the graph. Every one. 2.7 is right here. There's a point on the graph. 1,000.2 is going to have a point on the graph. So whenever the domain's all real numbers, there's no way you're going to write it as an inequality. Okay? All right, so interval notation, and then all real numbers on my math lab. Over here, can you tell me what the domain is just from our discussion
Yeah.
for this one?
Negative.
So remember this keeps on going like this, right? Okay, keeps on going like this, and this keeps on going like this, correct? All right. So when x is negative 1,000, am I going to go point the graph down here?
Yeah.
Negative 1 million?
Yeah.
Negative 5 billion? Okay. What about 2,000? 4,000?
Yeah.
And so on. So what do you think the domain is? Negative infinity to
Infinity.
positive infinity. Negative infinity to positive infinity. That's what kind of notation right here? Interval. On my math lab, you're going to say what? All real numbers. All real numbers. Okay. All right, let's look at the next one. Let's do the circle. We're going to do the circle this time. All right, so listen carefully to this. Use a straw to help you. Use a straw. Go to the circle. Okay, let's do the domain this time. And let's do the interval notation first. So the domain, as I said, of which coordinates? X. You take the straw and you move it along which axis? X-axis. Notice when I move along the x-axis, where do I start touching the graph? When x is what?
Negative 2.
No,
I mean negative 1.
negative 1. So I go from negative 1, and notice guys, every point that's in here, and how many points are between negative 1 and 5?
6.
No. How many numbers are between negative 1 and 5?
1, 2, 3, 4,
7.
Okay, y'all are counting. This is what y'all are doing. Oh, there's negative 1, there's 0, there's 1, there's 2, there's 3, there's 4, and there's 5.
To infinity and beyond.
What about 4.2? What about 4.276? So I'm going to ask you again now. How many x values are between negative 1 and 5? An infinite number. You just don't count the whole number. You're forgetting all about the decimals.
Well, why is it infinite if the line is on, I mean, if the,
If they stop.
Okay, so here's something that throws people off sometimes. They think infinite means the whole number line, right? But you forgot this when you learned this. I'm gonna draw this number line. 1 to 2. How many real numbers are between 1 and 2? That's a tough thing to think about. How many real numbers? I didn't say whole numbers. I didn't say integers. I said real numbers. A real number could be a decimal. And I'm going to ask you this. Is 1.2784910 6, 8, 2, 0, 1 in here?
Yeah.
Yes. Isn't that a real number?
Yeah.
Can't you have a real number with 1,000 digits?
Yeah.
Yes, you can. That's a difficult concept to see. So I'm going to ask you again. How many real numbers are between 1 and 2? An infinite number. An infinite number of real numbers are between 1 and 2. You can't count them. You just don't say 1.2 is in here. You can say 1.26. You can say 1.267. You can say 1.20854, right? There's an infinite number. Okay. It's a tough concept to see. Because when you think infinite number, when you think all real numbers, you think the whole number line, an infinite number, all real numbers. But that's not always true. 1 to 2 represents an infinite number of numbers, but that's not all real numbers. Because remember, I just said here, right? I didn't say anything about beyond 2. I didn't say anything below 1. But there's still an infinite number of numbers between 1 and 2. Okay? There's no way you can list them. No way you can list them. All right, so I'm going to go through this again. Let's talk about domain. I go from, what's the smallest x value? Negative 1. Every number on here is part of my domain. Because if I look at this point right here, do I get a point in the graph?
Yeah.
Yes, I get a point in the graph. So it's going from negative 1 all the way to what? 5. Negative 1 all the way to 5. So as an interval, you're going to say bracket negative 1 comma all the way to what?
5.
5 with a bracket. That's your domain. Bracket -1 to 5. And how many numbers are in there?
Infinite.
An infinite number. That's why you can't list them finitely like you did the 5 set of ordered pairs we did earlier. All right, now let's talk about how to write this as an interval. Okay. Notice that when we did this one, we said that my y coordinates are bigger than or equal to what? 1. Okay? When I do this one, listen to my words. My x coordinates, remember domain x, my x coordinates are between what? -1 and 5. Notice I use the word between, right? Okay, so listen, I'm going to write this. Y, I'm sorry, I didn't mean y, I meant what? X. My x's are less than what number?
5.
5. Less than or equal to 5. But they also have to be bigger than or equal to what?
1.
-1. So that is your inequality. So notice x has to be less than or equal to 5, and they also have to be bigger than or equal to what? -1. All right. So -1, 5. Make sure that these symbols are pointing in the same direction
Every time.
every time. Whenever you write it like that, it's got to be pointing in the same direction. So that means that if you look at this, that -1 is the smallest x value, because x has to be bigger than or equal to 5, or -1 has to be less than or equal to x. And at the same time, x has to be less than or equal to what? 5. Okay? Now let's talk about the range. Range, you go from bottom up. So what is the smallest y value I touch? -3. What's the largest?
2.
Nope,
I mean
3. So you're gonna, as an interval, you're going to say what?
Bracket -3,
Comma,
3.
3. You always go from smallest to largest. So writing as an interval is pretty easy. Now let's talk about how to write this as an inequality. You do it just like we did this one. So my y values are between what two numbers? Let's start with the smallest. -3 and what? 3. So how are you going to write this? You're going to say y is less than or equal to 3, and at the same time bigger than or equal to what? -3. That's how you write it. Okay? All right. Now, let's look at the next one. Let's do the domain first for that one. Notice you have some arrows here, right? Okay. So these arrows are pointing which way? To the left. So you're thinking what idea here? Negative infinity. So when I do the domain, I'm going from negative what? Infinity. And tell me if I need to stop anywhere or keep on going.
15.
Stop at 15, right? Okay, so when x is 15. So my domain, as an interval, let's do the interval first. It'll be what? Negative infinity,
Negative
parentheses,
infinity.
or brackets. Parentheses, good. Comma,
15.
all the way to 15 with a what?
Bracket.
Bracket, very good. All right, so that's my domain. What about as an inequality? So that means that my x values are what? Greater than what?
Negative infinity.
No, you never say that. You got to use a number. You never say in an inequality, never use infinity, negative infinity. You got to use a number. You got to use 15. So how are you going to write it? X is what? Less than or equal to 15. That's how you write it. That's what that says. So all your x values are less than this, right? Less than 15. Okay, now let's talk about the range. All right, range. Range, you go from bottom up. So I'm going to ask you this. Is there a smallest y value on that graph?
No.
No, because the arrow. Remember that? Is there a largest y value on that graph? No, because of the arrow. Keeps on moving it up. So what do you think the range is?
Negative infinity.
to
To positive infinity.
positive infinity. All right, so the range, negative infinity to positive infinity. That's your range. Negative infinity to positive infinity. Keep on going. Now, remember, how else on my math lab are you going to say this?
I don't really know.
All real numbers. All real numbers. Okay. All right, so that's that one. Let's look at the next one. Let's look at the next one. The next one is the absolute value. All right, look at this one. Let's do range first. The range is probably easier. So remember, the range is a set of which coordinates?
The range.
The y. So you go from bottom up. Always start from bottom up. So notice the arrows are pointing which way?
Down.
Down. So is there a smallest y value?
No.
No. So you're gonna use what idea? Negative infinity, all the way to what y value? 4. So my range is negative infinity to 4 with a bracket. Now we got to indicate that as an inequality. How do you write that as an inequality? Maybe you got to use y because this is range.
Y is less than or greater than 4.
Less than or greater than? You mean less than or equal? All right. Y is less than or equal to 4. That's your range as an inequality. All right, let's talk about domain. What do you think the domain is?
Negative.
Negative infinity what? Infinity. Negative infinity to infinity, right? Negative infinity, because remember it keeps on going like this. So think is negative 100 on this graph? Yes, somewhere around here. Is negative 1 billion on this graph? Yes, somewhere around here. So negative infinity all the way to what?
Infinity.
Positive infinity. On my math lab, you're going to say what? All real numbers. All right, let's do one of these and not both. So here, notice here, it's a finite set, right? All right, I'm going to ask you this. What's the domain? Tell me what you write. Just do it in order. So let's look at this point. What's my x? Negative 9, comma, what's this x? Negative 7, comma, what's this x? Negative 4, comma, what's this x? Negative 1, what's this x? 2, what's this x? 5, what's this x? 7, and what's this x? 8. Not an interval, right? Because an interval represents an infinite set of points. Not points, but a set of values. That's not an infinite number. That graph represents a finite number. So we got to recognize that, hey, I've got to write this as a set of finite numbers here. Now, there's no way you can write this as an inequality because inequality represents an infinite set of numbers. All right, so that's all you can do with this. What about the range? What's this y value? Yeah, just go from left to right. What's this y value? No, negative 3, right? What's this y value? Negative 5. This y value? 2. This y value? 5. This y value?
2, we have it already.
No, what's this y value?
I'm sorry,
1. What is this y value?
Negative 4.
Negative 4. What's this y value?
Negative 8.
Negative 8.
6. Did I miss
Negative
one?
6. Nope. Negative 6. Looks just like an 8. And what's this y value? 2, which we already have. All right, and that's it. That's all you do. All right. Now let's look at the lines. Let's look at the lines. Let's do domain. X from domain set of x coordinates. So tell me what you think the domain is.
Infinity.
Negative infinity to infinity. In my math lab, you'll say what?
All real numbers.
All real numbers. What about the range? Go from bottom up along the y-axis. Is there a lowest point? No, because they arrow, right?
Mhm.
So what do you think the range is? Negative infinity to what? Positive infinity. All real numbers. Okay? All right. Now let's go to the vertical line. All right, let's do the range first. Let's do the range first. You go from bottom up. Is there a lowest y value on that graph?
No.
No. So you're gonna say what? Negative infinity to positive infinity. Or all real numbers. Okay, now let's talk about the domain. Notice that when I go from left to right, I touch the graph here and that's it, right? I don't go any further because there's nothing else. So I need you to tell me what that x coordinate is.
-5.
-5. So here's how you're going to write it. The domain. Now remember, domain is just one number, right? So you write that as a set. So you're going to say brace -5. Okay, brace -5. That's your domain. It's just one thing. What is it? -5. Nothing else. And there's no way you can write it as an inequality because it's just one thing. What is it?
-5.
-5. Okay. Now let's look at the horizontal line. The domain here is easy. Let's do the domain first. Domain set of which coordinates?
X.
X. So tell me from
Negative infinity.
negative infinity to positive infinity. Or you can say our real numbers. All right, now let's talk about the range. Range, you go from bottom up. So tell me when I start touching the graph. Right here. Nothing else. I stay there. Tell me what all these y values are. 5. So you can say the range is just what? 5. Just like this. Okay? All right. So quite a bit of information here dealing with domain and range in terms of the graphs. Intervals, infinity, negative infinity, inequalities. Okay, so I need you to, if you need to, go back and look at those videos to help you. Okay? All right, now let's talk about this.